Hello and welcome to the lecture, How to Identify Minerals. In this lecture, I will be demonstrating how geologists and earth scientists use the physical and chemical properties of minerals, but I will also be discussing why the identification of minerals is important in the earth sciences. So, whenever you start looking at a mineral is nothing more than a naturally occurring inorganic solid with a definite chemical composition and an orderly internal arrangement of atoms. Now, all of these criteria are important because what they do is they set a foundation for what a mineral actually is. But in this video, what we're going to be looking at is why is the actual identification of minerals important and how do we go about accomplishing identifying minerals. So, whenever you start asking the question of why is mineral identification important, because this is an essential skill of a geologist because it's necessary to identify rocks, okay? And so by looking at the minerals that make up rocks, we are able to get a better understanding of the landscape as well as provide a geologic history of a region. And so because certain minerals form in certain environments, this provides geologists with clues to interpret past landscapes. Okay, so that's why mineral identification is important, because minerals make up rocks and it just accumulates material that helps us to put together the story of this landscape. Okay, so whenever we start looking at identifying minerals, one of the things that you have to look at is how do we go about doing this? Well, geologists and earth scientists use a variety of tests, okay, as well as observations of physical and chemical properties of that specific mineral. So what we have to realize is that each mineral has its own unique set of physical and chemical properties, and this allows us to identify minerals in the field that are much harder to do so. It allows us to distinguish those minerals even though they don't all look exactly the same. Okay, so it's really just using these properties that is going to really help you out in identifying these minerals. All right, so here's what we're looking at. One of the first things that is obvious about our mineral is its external expression. Okay, so in other words, what it looks like. And this is all because minerals have orderly internal arrangement of atoms. Okay, and that internal arrangement of atoms is what actually gives a mineral its unique set of chemical and physical properties. Okay, yes, the internal arrangement of atoms doesn't deal much with the composition of the mineral, but it does determine what the mineral actually looks like. For example here, if you see diamond and graphite, both of these are made out of elemental carbon, but yet because the internal arrangement of the atoms is different, each one of these has a different external appearance. Not only that though, they also have different properties. So even though they are both made out of carbon, it's simply that internal arrangement of atoms that gives them their different properties. And this is what we're going to be looking at. Everything dealing with minerals talks about that. All of these properties we're going to distinguish talks about the internal arrangement of atoms. Okay, so what properties do geologists actually use? And so with this, here's what we got. First one is luster. Whenever you start talking about luster, luster is nothing more than the quality of reflected light from the actual surface. Okay, there are two ways that we actually describe luster. Luster is either going to be a metallic luster or a non-metallic luster. Now, the reason that this one is first in this course is because your mineral identification key is based off the physical property of luster. Okay, and so whenever you start looking at it, you're going to pick up that mineral or you're going to observe that mineral and you're going to ask yourself, okay, is this mineral a metallic mineral or is it a non-metallic mineral? And then from there, what you're going to do is you're going to determine, okay, which part of the key I actually use. So whenever you start doing mineral identification, it's all about process of elimination. Okay? Next property is going to actually be color. Okay, these are two of the most obvious that you're going to see. But the thing that I will tell you is that whenever you start looking at color, this is one of the least reliable properties. And the reason being is color is often a different chemical that is actually present in the actual mineral itself. So the perfect example that I'm using here is quartz. You can have what is called just pure quartz, colorless quartz, and that's going to be almost 100% pure silica. Okay, whereas if you look at something like rose quartz, it's because it has an impurity of titanium. Amethyst has iron, and there's several other actual compositions or impurities that can be added to a mineral that gives it a slightly different color. Okay, and so that's what you're looking at here. The next property we're going to be looking at is streak. Streak is actually the color of the mineral in its powdered form. So the best way to actually determine the streak of a mineral is to scratch it along a porcelain plate. And so what you're going to see here is you may have gray minerals, but as soon as you scratch them on a streak plate, you're going to get a red streak. There are other minerals that you can scratch that is going to be like, whoa, that's a completely different color than what it appears on the outside. Okay, so this is a good property on specifically, there's some minerals like hematite, like you're seeing here, where it's going to be a real good distinguishing property that you're going to use to differentiate it from something that looks very familiar, like magnetite. Magnetite and hematite look very much the same, but because they have different colors of streak, you're able to differentiate them. Next, we're going to be looking at the hardness of the mineral. And whenever you start talking about the hardness of the mineral, this is its ability to actually kind of scratch glass. So of course we use a glass plate for this. And so what you end up doing is you take your mineral and you're going to scratch it along the plate. And if you take it and scratch it along the plate and it does not scratch it, that means that the hardness is somewhere between 1 and 5. Okay, 5 will not scratch glass, whereas if you take it and scratch the actual glass plate, then you know it's anywhere from 5.5 to 10. Now, whenever you start doing this, please realize that the hardness is not always going to be easily discernible. So other times you can use it to say, I'm going to scratch other minerals and such. And so because of that, that's why you get those, that'll help you distinguish which mineral and what the true hardness actually is. And of course, one thing that we actually use is what is called the Mohs hardness scale. Okay, so next we're going to look at probably one of the more challenging actual properties, and that's going to be cleavage. Cleavage is the ability of the mineral to break along weak planes of bonding. And so whenever you start looking at this, you can start looking at thinking of it this way, that if I were to take that mineral and hit it with like a hammer, it's going to break off in the same exact shape as it's actually distinguishing in its original form, so larger form. So for example, if I were to take any of the 2 upper left minerals and hit them with a hammer, they would break off with cubes, break off in smaller cubes, but they would all look the exact same. That's because these minerals actually demonstrate cleavage. Okay, biotite and muscovite have one direction of cleavage, and so if you were to take a knife and just pry in between them and like rip it apart, you're going to get another sheet. These are your micas, biotite and muscovite. Okay, so what you can do is you can actually look at, does the mineral actually demonstrate cleavage? As compared to fracture. Fracturing is not cleavage. Like if you were to take a piece of quartz and hit it with a hammer, what you would do is you would get like a little, it looks like a contact lens. So have you ever seen where your windshield has taken a rock to it, and you notice you get that little contact lens shaped indentation where the rock hit? That is fracturing. And the reason that your windshield does that is because quartz, which is used to make your windshield, has fracturing and not cleavage. Okay, and there you can see a perfect example of that. Okay, there's the cleavage fragment, and then there's the fractured fragment right there. So that's one of the distinguishing characteristics. It's very tough to see though originally. Next is specific gravity. What this does is, specific gravity is just a different way for a geologist to actually compare its densities. But what it does is it's basically saying specific gravity is taking it taking the mineral and putting it into an equivalent amount of water. And then so what you end up doing is because you're putting it into water and then measuring its mass, what ends up happening is you end up canceling out the units. So specific gravity is one of the only measurements, or yeah, it's one of the only measurements where you actually have no unit assigned to it. Okay, and that's why whenever we did the density assignments, we always put the unit on so that we can differentiate between density and specific gravity. And specific gravity is just one on certain minerals, specifically your metallics, that'll really help you out. Then there's a whole bunch of little ones that you can actually do. There's certain ones that kind of help distinguish. You can use smell, magnetism, refraction, taste. For example, you could see at the very top in the center, magnetite. Magnetite and hematite look alike, as I mentioned. You can use their streak as one distinguishing factor. Another one is magnetite is magnetic. Halite at the top right, if you were to actually lick that mineral, that is actually salt. That's where our salt comes from. Gold has malleability, so if you remember the old prospectors taking and putting it in their teeth and bending it, that's malleability. You would not do that with pyrite, which is fool's gold, because you're going to break your teeth. Double refraction, you can see there, is really good for halite and calcite, and then you can have your smell of sulfur, which is going to be a distinguishing characteristic. So basically what you end up doing is you use a whole variety of different of these properties, and you test these properties to kind of narrow it down. Now, one of the most useful properties is going to be what is called the effervescent fizz. The effervescent fizz is not a physical property that you're looking at, but rather it is a chemical property. So anytime that you actually put hydrochloric acid onto a mineral and you get this effervescent fizz, that is an automatic indication that this mineral is a member of the carbonate family. Okay, so it has the CO3s actually in its chemical composition. So that's very, very useful in actually determining which mineral you actually have, because you can look at its chemical composition in this aspect. Of course, if it doesn't react, then if you're looking at it's most likely either a silicate, unless it puts off an odor or smell, then you know that it's a sulfide or a sulfate. So by using the effervescent fizz check with hydrochloric acid, you can determine if it's a carbonate or not. So, and one of the last properties that we're looking at that's kind of very unique is using a black light. We're going to look at fluorescent. Certain minerals provide fluorescence, and others that look exactly like them do not. And so calcite being one of those, calcite actually has a fluorescence to it. So as you can see, there's a variety of properties that you can actually use. Now, whenever you do mineral identification, what you end up doing is you just end up saying, okay, I'm going to go through as many properties as I can, and I'm going to look at my key and say I'm going to narrow it down to the one that's left. Okay, and so whenever you start looking at it, let's say this mineral right here, the first thing that you're going to do is you're going to identify this mineral. And because of the way that the key is set up that I've provided you, you're going to first focus on its luster. So you would ask yourself, okay, is this a metallic luster or a non-metallic luster? And if you said metallic luster, you are correct. So you would be actually using the metallic luster portion of your key, which is the first page. Okay, so it's only limited to these minerals. And that's because the second page begins your non-metallic lusters. Okay, and so what you do is you have automatically narrowed it down now to just your actual metallic minerals. So now you know that this mineral that we're trying to identify is one of those minerals. Okay, so you look at it and you said it's metallic, so now I know it's one of these. Next thing I'm going to do is I'm going to check the hardness and streak of this. And I see that I have a gray streak and it did not scratch glass, which indicates that the hardness is below 5. And so what I end up doing is I see that it has some cubic cleavage. And so going through my actual key, I'm looking for a gray streak. I'm looking for a hardness below 5. Okay, so that automatically knocks out magnetite and pyrite because those are above 5 looking at the hardness. So I know that, okay, this is where you can start to use color now. You can be like, all right, I'm going to start saying that that is silvery or gray. So we got silvery or gray, so it could be silver. It could be galena. It could be hematite. Now, what I start looking at then is I start to say, all right, some of the things that were obvious to me is this thing had cleavage. So let's look at that. Many forms of luster can be massive. No cleavage for hematite. Oh, perfect cleavage. 3 at 90 degrees occurs in cubes. Silver, no cleavage. Okay, lack of cleavage. So automatically, what did I just do? I just narrowed it down to the sample that I was identifying is galena. And so you use that same process every single time. You just basically use the primary properties, and you actually use those properties to narrow down which mineral you're trying to identify. So hopefully this video explains to you how you go about identifying minerals. There is no set procedure. There is you just go through a series of tests, and then you use your skills of observations to actually see which mineral you are actually left with. So this concludes the lecture on how to identify minerals, and I hope that you found it useful in the study of geology and mineral identification.